Hello, everybody. We're going to be talking about additional inner join using SQL. So let's go ahead and start it right away. My query is going to be based on two tables, the employees tables and the orders table. So let me go ahead and show you the employees table. It's going to be employees ID, last name, first name, birthday, photo, and notes. And the orders tables, as you notice, it has multiple fields. Order ID is one of them. That's the primary key for that table. And you notice here it has the employee's ID. Since the orders table has the employee's ID, therefore, it is the many in the relationship between orders and employees. So employees is the one and orders is the many. So employee's ID here is the foreign key that is going to link the two tables. Let's go ahead and create, just to show, the orders for every name. Then my ultimate goal is to go ahead and calculate the number of orders for each employees. I'm going to be using the employee's last name to indicate which one of those employees belongs to which number of orders that I'm going to do later. But before we do the number of orders, let's go ahead and do just a list without having any aggregate function like count or sum or max and all that. And you will see here, starting with the select employees, that's the name of the table, dot last name. Then we're going to say also give me the orders order ID from the orders table. Okay. All right. From, that's the inner join, orders. Okay. Orders inner join on employees. Now we're going to link the two tables based on the relationships. We're going to say on employees, inner join employees, on. Now we're going to say orders dot order or employees ID. That's the foreign key here. Employee ID equal employee ID. And if I run this, hopefully I didn't misspell anything. There is a syntax error here. Order inner, okay, I miss here, join. Okay. And you notice we're going to really see scattered because the order ID is going to be picked up from the orders table every time we have a matching name. So if you take a Buchanan, you're going to find Buchanan everywhere here. So my ultimate goal here in this query up to this point is to find how many orders Buchanan has made, how many orders Davilio has made. So what are we going to use? We're going to use the count function around, not the last name, around the order ID, because that's the many, and that's what can be countable. All right, because there is only one last name, one last name that is going to be repeated for every order. So at this moment, that's not going to do anything. If I run this, it's going to give me the total count for everybody, which is going to be 196. That's the number of the record basically on the data, in the table. So in order for me to benefit from the use of the count, we have to go and say group by. I need to group it by some field. In this case, I'm going to group it by the last name. So I'm going to group it by the last name. Why it's the last name? Because for each last name, we're going to have a number of the records that is going to match that last name. So here we go. If you notice, we have Buchanan who made 11, Callahan 27, Peacock is 40, Leverling is 31, and so forth. This works wonderful. Notice that the group by only can work when we apply the count here in order for us to group or calculate something based on an aggregate demand function like count or sum. What I wanted to show you here on this, if I wanted to go ahead and find, after I did actually group everything, which is great up to this point, what about if I wanted to find those employees who did have over or equal to 20, greater than or equal to 20 orders processed by them? So in order to do this, you might think initially about where. I'll say here where, okay, where the count of orders, as we did it here, dot order ID, okay, is going to be greater than or equal to 20. You will notice this is not going to work because the where clause is not going to work around a aggregate function or with an aggregate function. It doesn't work with it. Where would work with one attribute when we say like where last name is equal to Smith or where first name is equal to Ty. Those are fine. Where city is equal to Seguin or where country is equal to United States of America. But it doesn't work with the aggregate function. In order for us to select the criteria based on the use of aggregate function, we have to use the keyword having used with the aggregate function having. So please keep a very good notes of this keyword that is going to be extremely important for us when we use aggregate function. So having the count orders.order ID. Of course, I could have an aliases to the count. So the count orders order ID can be referred to as the number of orders, which is more meaningful. And I could actually take that out also and use the number of number of orders, and so that should work. It's the same thing. It's not going to change my outcome. But notice this is a value that is based on aggregate function. That's why it works with having. The reason I'm using it now as an alias is because I don't want you to confuse in the future that even I'm using a name for something, it has to be based on an aggregate function in order to use the having. And we had to use the aggregate function in order for us to actually group the data together. I hope this has taught you something, and we'll continue with the next video. Thank you.